Hey YouTube, what's up? Welcome back to another video in the series where I try to create my own tech company. If you've been following along in previous videos, you'll know that what I'm doing is trying to build a game using Phaser.js, and then I'm also building a website using Next.js and Supabase to control who has access to that game. And my business plan is to charge a monthly subscription fee for people to play the game that I'm building. That being said, building games takes a long time, and it takes much longer when you don't know what you're doing and you're just trying to figure it out week to week, which is what I'm doing. But it's a slow and steady process, and I appreciate you following along. So over the course of this past week, the changes that I've been able to make to my game, hopefully you can see on the screen right now, a large pink box that exists on top of my hero sprite, and it moves as I move the hero sprite around my game. The enemy that we added last week to the game is also no longer moving around randomly. Instead, he's idling and he has a sleeping animation. And when this pink box, the large one that I'm calling the Hero Presence Collider, once that overlaps with our enemy is going to wake up and then take the shortest path to behind our hero, and he's going to attack. So you can see there he's taking the shortest path to get behind our hero, and then he's attacking. There's about a 1 second delay between the enemy knowing what position our hero is and him moving to try to get to that position. And what that does is it allows our player, our player, to run away from the enemy. And you can see here that I've managed to get the enemy outside of my Hero Presence Collider for about 1 second, which will stop the enemy from following my hero because he doesn't know where I am anymore. So that's great. That was one of the first goals that I wanted to accomplish this week. Really one of two major goals that I wanted to accomplish this week. So now that we've got an enemy that will attack your hero, we also need to motivate our players to play the game. In keeping with a joke from a previous video, this game right now is essentially bush cutting simulator. And when you cut those bushes, I wanted to spawn an item, and that item is going to be a coin, and the more coins you pick up, your score is going to increase, and then once the game is over, high score wins, essentially. So I needed to add functionality that when you cut down a bush, an item will spawn. So I added that function. Every time you cut a bush, we have a spawn item function, which will spawn one of two items. It will either be a coin or a heart. And the goal here was that a heart would increase your hearts, your total life. You can see here that we spawned a coin. I will say that I have not coded the ability to pick up these items yet. That's something we're going to have to cover next week. But when your hero character overlaps with one of these items, be it a heart or a coin, it should do something for one of those items. If it's a coin, it should increase your score. If it's a heart, it should increase your life. Let's see if we can cut a bush and see what a heart is going to look like. All right, there we go. So we've got a spinning heart down here, and up here you can see a coin. So those were kind of the two major changes this week. I did add one more thing, but maybe we'll cover that at the end. So let's take a look at the code for these changes first. If we jump here into the code of our test scene, on line 197, we added the Hero Presence Collider, which is an interactive game object. That's a utility function that I've also covered in a previous video, but that's essentially creating that large pink rectangle that you see on the screen. And in order to track our hero's position, we're keeping track of that inside of the Hero Action Collider update function on line 208. We're just setting the position on our Hero Presence Collider object. As we update that, we're tracking our hero sprite's X and Y values and setting it inside of that collider function. Okay, so moving on, trying to go a little bit quicker this week, let's jump down to line 299. So after we've created that Hero Presence Collider, we need to create an overlap in our physics engine between that Presence Collider and our enemy sprites. Enemy sprites, plural, is an array of all of our enemies, because in the future, we're not only going to have one, we're going to have multiple of these guys running around our map. So inside of that overlap function, the first thing we need to do is figure out which object is which. That function takes in two objects, and then an anonymous function. We take an object A and object B inside of that anonymous function, and we need to execute a find function to determine which is which. So we're saying our enemy object on line 303, our enemy constant, that variable, is whichever of those two objects that is not the hero presence collider. And then we're doing all of that logic here, lines 307 down to 344, it looks like. So if our enemy can see our hero, we set the is following hero property to true, and then we get the hero's back position, and then we're going to set the speed of the enemy and move that enemy to the hero's back position using the closest reachable path. Okay, that's pretty straightforward, pretty simple. Let's jump down to line 387, which is the second physics overlap that we had to create. So the first one is going to handle the hero presence collider in our enemy, and when those two objects collide, or overlap, I should say, the enemy will move towards our hero. The other one that we needed to add is between the action collider, which is the smaller box that exists in front of our hero at all times, and our interactive layers. If you remember from a previous video, the interactive layers are bushes and boxes. Now, we're not handling anything with boxes yet. You can see them around the map, but maybe we'll add that functionality in the future. So between our hero action collider and those interactive layers, if the tile wasn't handled already and the index is 428, which is the index for bushes, then we're going to execute some logic. So if we are attacking, on 399 we set the tile was handled to true. This was an important lesson that I learned this week. Essentially, the is attacking state of the hero exists for the entirety of the hero's animation, but this overlap is a constant and is constantly being updated in the update method of the scene object. So when my hero was swinging his sword, we were actually calling this spawn item function around 40 or 50 times and spawning a bunch of items. And in order to prevent that, we created this was handled boolean on the tile object to make sure that each tile can only be destroyed once. So we're going to set that to true on line 399. We're going to have a slightly delayed call to allow for that attacking animation to really finish, or at least get into the middle of it. And then we're going to spawn an item on top of that tile. So we added this spawn item function this week. Let's see if we can find it. It's further up. So jumping up here to lines 52, we have this spawn item function, which exists on the scene object. This is going to take in a position and then do something. It's going to spawn an item, maybe based off of a position that it takes in. So in debug mode, that's a 50% chance. In production mode, this will be a 1 in 5 chance. And then if there is you hit that 1 in 5 chance for an item, there's a 50% chance for that item to be a heart and a 50% chance for that item to be a coin. Inside, if you get one of those, like if you happen to get that chance, we're going to add one of those sprites. So we're going to call this.physics.add sprite, pass in that position, and then add either a heart or a coin. But in order to add a sprite, we also need assets, which is something else that I had to do this week. I used Texture Packer, which I've talked about before, to create sprites for the heart and the coin animations, and we're bringing those assets inside of our preloader file. So on lines 18 and 19, we're loading the item atlases, and then that allows us to reference those keys on lines 60 and 68 respectively to add either a heart sprite or a coin sprite. Then at the end of those if blocks, we need to play the animation for those sprites after they've been added to the scene. And a little bit lower down in our create function, I'm handling the creation of those item animations. That was another thing that I did this week, was to create a utility function to create item animations. And it takes in the animation manager context inside of the scene, and then a string to determine which item animation it's creating. So jumping over to that file for the utility function, this is what it looks like. It takes in, like I said, the animation manager and an item key, and it will create animations using that animation manager and that item key respectively. That's most of the work that I did this week. It wasn't a monumental amount of code changes, but it was a lot of figuring out how to make all this stuff work together. So now we're spawning items and our enemy is attacking our hero. But what happens, assuming we can go around and pick up these items, once our hero loses all of his health. Let's see. So the enemy is going to take the shortest path to get behind our hero, and he's going to keep attacking. Our camera's going to fade to black, and now we're starting this new scene, which is a game over scene, which also allows our user to play the game multiple times after pressing space to restart. It will reset the state of our game. That is occurring in our test scene, in our take damage function. If the hero sprite, line 114 right here, if the hero sprite's health is less than or equal to 0, after fading out the camera, we are starting a new scene and passing in the experience and the level to start our game over scene. That's a very simple scene. It takes in some data, which we've covered previously in a video. It's going to add some text to say game over, and then to inform our user to press space to restart. And then in the update function of that scene, we're going to listen to our keyboard inputs, and when a user presses the space key, we will start the test scene again and pass in the experience and the level that we need in order to start that scene. Okay, so those are the changes that I made this week. There's still a lot of work to do, but we're so close to getting our game at least to an MVP state where a user can play the game repeatedly, get a high score, and then maybe in the future we'll build a leaderboard or something like that, maybe using Supabase for a user to see other scores of other players playing the game. But that'll be a future video. If you made it this far, thanks for watching. I really appreciate anyone who is watching these videos and following along on this journey week to week. And yeah, I appreciate it. Thanks for watching. Have a good one. Bye.